Okay, so today we've spent 2 lessons on the parabola, and we ended off quite strong last week by looking at exam questions. If you remember, we were doing all sorts of cool stuff with reflections and the axis of symmetry, and you guys were on fire, I must say. Today we are going to tackle the hyperbola. And remember, this is our foundations course. So we really spent some time going over the basic ideas of functions. And in about 2 lessons time, we're going to get to those inverses. Okay, so stick around for that if that is what you are struggling with, waiting for. But spend time working on this foundation, because this stuff, as you'll see tonight as well, this stuff's in your exam. It's in your grade 12 exam as well, even though it's more like grade 11 work. But it always gets asked. And before we can do the inverses, we must have a good grasp of each function as it stands. Okay, so the hyperbola, wait, I forgot something, Miss Coco. Oh, house rules. House rules. Some of you know the house rules very well by now, especially the veterans. Our house rules are just that you please stay on mute. If you do have a question, just raise your hand like you would in a normal classroom. I'll ask you to unmute yourself and ask your question. And then when you're done speaking, just mute yourself again so that we keep the quiet of the room and not have too much background noise or anything to disturb people. The chat is only there to post about the lesson. Please do not make any direct exchanges with each other. Just stick to chatting to myself and Ms. Coco and to posting answers and questions in the chat. So for those of you who have been here a while, you know how all of this works already. Newbies, that's basically what we do. We post our answers in the chat. Having said that, this is very interactive and you must have your pen and paper calculator with you, because you are going to work hard in this lesson. And I challenge you to try everything, because it's only through trying and making mistakes that we learn. Okay, so mistakes happen all the time. I make mistakes. You'll see me make quite a few mistakes in the lesson, but it's fine. Okay, we just move on, we learn, and we move on. That is what this is all about. And in the meantime, we also try and have fun, and Ms. Coco and I will crack some really lame jokes, and hopefully you'll laugh at us when we do so. Ms. Coco is our lovely teaching assistant. So if you have any technical issues or need any assistance of any sort, you can DM her and she will be right there to help you. Hey, Ms. Coco, do you want to say anything?
I did. I was about to say you forgot gorgeous and intelligent, but
of course. How could I?
But, yes,
gorgeous, intelligent,
lame, but lame
funny.
jokes. We'll get many of those. Yeah, guys, if you have any problems, just send me a DM and I'll be more than happy to help.
Cool. Okay, so back to our hyperbola after all of that. So the hyperbola is the function where x is in the numerator. So x is a fraction. The normal sort of just what I call the baby or the mother function. Yeah, I guess you can't be a baby and a mother at the same time, but this really is the mother graph of the hyperbola, which is 1 over x. Remember, our f of x is just function notation. We can replace that f of x with a y. Y is 1 over x. And if this is the mother function, then it can be shifted left, right, up and down. If we shift it left or right, we are going to add and subtract from the x's. And that is what we have done in this second sketch over here. 1 over x minus 2. And it is also a bit counterintuitive. By subtracting 2, we're actually moving the graph 2 units to the right. Okay, so this is moving it left or right if I add and subtract from the x's. If I just add or subtract from the 1 over x, that is shifting the graph up or down. So in this case, it's -2, so we've moved the graph 2 units down. That also gives you your asymptotes. If you guys are wondering what that noise in the background is, it's my puppy. She is growling for some reason. Sorry about that, but she'll settle down in a minute. So as I was saying, left or right, up and down, and then these values also form our asymptotes. Okay, so we're going to look to whatever was added to the x's for our vertical asymptote, and our horizontal asymptote is whatever we subtract from the 1 over x, or add if we are moving it up. Our quadrants, so A is the value. So in these examples, A is just 1. But if A is a positive number, we draw in the first and the third quadrant. That's where we're going to place our hyperbola. And if A is negative, we draw in the second and the fourth quadrant. So I'm going to talk a lot more just now about the asymptotes. Okay. What I just want you to understand up to this point is that we can shift left and right. And by doing so, we add or subtract from the x's or from x, and moving up and down is this number here, where you just do it from 1 over x. So the exponential graph, that's next on our list. Okay, we're doing parabola. We've done parabola and straight line. Today we're going to do hyperbola, and in our next lesson we're going to cover the exponential one. Yes, and these are confusing, but if you make a summary of each graph, like this one, like the one I'm showing now, okay, and you make like a 1-page summary of all the graphs, and you study it, that really, really helps. You got to know it. They say maths isn't a study subject, but there is a lot of stuff that you can study in maths, okay, and this is one of the things, like the features of the graph. How do I know which quadrant to draw in? If A is positive, I draw in the first and the third quadrant. If it's negative, I draw in the second and the fourth. Those are things that you must know, like really know very, very well if you want to improve. I see Andiswa says she thought my dog was a motorbike. Yeah, maybe, eh? Cool. Okay, so let's move on and talk a bit more about the asymptotes. So this is the equation of the hyperbola. Y is a over x minus p plus q. And so the x minus p is your horizontal shift, but it is also your asymptote. Your x equal to p will be your asymptote. Okay, that's your first asymptote, and that's the vertical asymptote. I hope you are writing it down, making big notes for yourself in order to understand this and to really learn it the way that I've explained it just now. Okay, plus q is your vertical shift, and it's also your horizontal asymptote. Now, don't get confused. I see so many people get confused. They think that this is a y-intercept, but the y-intercept you have to calculate when it's a hyperbola, okay? So when we have a straight line and a parabola in its standard form, then we can read off the y-intercept, but not for the hyperbola, okay? Hyperbola is a different story. It tells its own story with the numbers in the equation. And remember, your A is going to tell you what quadrant to draw in. How do we recognize it as a hyperbola? X is in the denominator. Okay, so that's how you must basically know it, and make sure that you understand those things, that it becomes like second nature to you. Okay, so we've got a shape. A is positive and A is negative with the quadrants. I've explained that just now. And then your two asymptotes, your vertical asymptote and your horizontal asymptote. Okay, Now remember, your asymptotes are there because at those points, the graph does not exist, okay? It cannot take on that x value or that y value that are the asymptotes, because at that point, the graph is undefined. That's what an asymptote basically tells you. There's one more thing here that we have to add, and that is the axes of symmetry. Axes of symmetry for the hyperbola, there's always two of those, x plus c and then minus x plus c. And then to calculate c, we sub in the point where the asymptotes cross. Just make a note of that so long, and we are going to practice that. It will make more sense when we actually do it. Where the asymptotes cross. Okay, so let's tackle our first sketching of the hyperbola. Okay, so we've got sketching this hyperbola, -1 over x minus 2 minus 1. Okay, so when we sketch, there's a few things we need to take into account or think about as we sketch and plan how we are going to sketch this graph. Okay, and remember, for the parabola, we had like a whole plan, the shape, the turning point, all of those key features had to show. So we're going to do the shape of the hyperbola first. So for the shape, we look at the a value, and that is this constant value that's at the top of the fraction in the numerator. And since that is less than 0, we can already plan that we are going to draw in the second and the fourth quadrant. Okay, that's because a is smaller than 0. Right, so the next thing we're going to do is our asymptotes. Not shape again, we've done shape already. Next one is asymptotes. Okay, so we look at our equation. Our asymptote, we need a vertical asymptote and a horizontal asymptote. So our vertical asymptote, we look at the x minus 2, right? And our asymptote there is going to be x equal to 2. Now, important is that you put the equation down. It is, if you just put down 2, that doesn't really mean much, okay? It has to be x equal to 2. And then our horizontal asymptote, you read off from the equation as well, which is this value here. And that is going to be y equal to -1. Okay, so asymptotes, guys, that must also be like, if you haven't understood it up to this point, please don't leave here today without understanding that. Okay, so that's our asymptotes. Now we need x-intercepts. As always, to find x-intercepts, we're going to make y equal to 0. And it's equal to 0. Okay, so to solve this equation, we can take over the -1 to the other side. That's +1. And then we're going to multiply both sides by x minus 2. We multiply by x minus 2 because we need to get this x minus 2 to not be in the fraction anymore. So that's going to give me -1, and then 1 times x times 1 times x minus 2 is just going to be x minus 2. Andis was asking, did 2 become positive because you substituted with 0? No, Andiswa. What we do is, I assume you're talking about the asymptote, x minus 2. So you basically say, what is going to make this denominator 0? So I'm not sure, maybe that is what you mean, but what is going to make the denominator 0 is if x is equal to 2. And the denominator can't be 0 because this is a fraction. Since grade 8, we've learned that we cannot divide by 0. So if x is 2, that will make this denominator 0. So that's why our asymptote is at x equal to 2. So Sanda, can't you take the -1 over from a division to a multiplication? I'm not entirely sure what you mean, Sasanda, to take the -1 over from a division to multiplication.
Ma'am, if I may, I think she may be talking about how you got from -1 over x minus 2, -1 is equal to 0, and then the 1 went over and became +1.
Yeah.
I hope I'm getting that correct.
So Sasanda, what I did was I added the 1 on this side, and then I added it on the other side as well. I took the -1 over to the other side. So that's how I got -1 over x minus 2 is equal to 1. And then I multiplied by x minus 2, which is in the fraction. So that leaves me with -1 is x minus 2. I'm going to add 2 on both sides, and I get x. I add 2 on both sides because I want to get x by itself. So then x is equal to 1. Okay. Can people just give me a thumbs up in the chat if you're happy so far with finding the x-intercept of the hyperbola? You can put it in the chat, or you can use your emoji in Zoom. Liam, Cassandra, hey Dean. Okay, got a good number of thumbs up so far. Great, so let's carry on and do our y-intercept. So for our y-intercept, x is equal to 0. So we're gonna make x equal to 0. Okay, the y-intercept always feels so much easier than the x-intercept. I don't know why. But this is going to be -1 over -2 is going to be a half. -1 is equal to y, and then y is going to be minus a half. Okay. Right. So there's most of our working done now. So I am going to go ahead and make an axis so that we can draw our graph. And I want you to do the same and see if you can draw this graph with all the information that we have just found. And once we've drawn it, we'll calculate the axis of symmetry as well. Okay, so let's see. I want you to have a go at it first. So we've said which quadrants we're going to draw, 2 and 4. Our asymptotes is at 2 and -1, and our x-intercept is at x equal to 1, and our y-intercept is at y equal to -1/2. Abigail, this is a hyperbola. It doesn't have a turning point, so we don't calculate a turning point for it. Okay. What you guys must understand, or just remind yourselves of, is that each graph is different. Okay, we don't do the same for each graph. They are different. We calculate different things for different graphs. Parabola has a turning point, so we do a turning point for the parabola. But hyperbola and exponential and straight line graphs do not have turning points. So we don't calculate turning points for those, but we do calculate other stuff like asymptotes. Like a parabola doesn't have asymptotes, so we don't calculate those for parabola. But our hyperbola's got asymptotes and an exponential graph's got asymptotes. Okay, I'm going to keep quiet for about 2 minutes so that you can draw your hyperbola, and let's hope we all get it spot on. Kolise, I think you must just check your calculations for your x-intercept. I have put it up on the screen. We did take the -1 to the other side and became a +1, and then we multiplied with x minus 2, and then we took the -2 back over to the left-hand side, and -1 plus 2 is 1. So just check your calculation again for that. No problem, not at all. Don't worry about it. Right, I wonder how everyone's doing with their graph. I'm going to start so long and put in the asymptotes. So we've got a vertical asymptote where x is equal to 2. Remember to make a dotted line with a ruler. Please use a ruler when you draw your graphs. It just looks neater. It's much easier to mark as well. And label it clearly so that whoever is marking your paper can see where you have drawn your asymptote. It's so sad if you had gone through all the trouble of working out the asymptote, but then you don't label it in your sketch, because then you get no marks. Sad face. Okay, and then we've got a horizontal asymptote at y equal to -1. Okay, label, label, label. Our graph has to go through, has to be drawn in the second and the fourth quadrant. Okay, so, and then we also worked out that the x-intercept is 1 and the y-intercept is -1/2. Okay, so that means if it goes through -1/2 and 1, whoops, that was unintentional scribble. Remember, it goes closer and closer to the asymptote and label your intercepts clearly. Clearly. You must show what your intercepts are. Sure, I can move it a little bit, no problem. So my x-intercept is 1 and my y-intercept is -1/2. Okay, and then there's another part of the graph that's just chilling in this quadrant over here. Okay, how's everyone looking? Who got it right? Please give a thumbs up if you got it right in the chat so I can see how we are doing with this. Wonderful. I see quite a few thumbs up. That's excellent. Should we not write the asymptotes in coordinate form? Leako, maybe if you can type it for me so I can see what you mean. It doesn't have to be in coordinate form. You do have to label where it goes through the x-axis and the y-axis, that's for sure. If you want to do even better than that, you can write the equation of the asymptote, y equal to -1 and x equal to 2. You can do that most certainly. Okay, well done, everybody. It looks like we are on track. How to determine your drawings for shape after drawing asymptotes. Why is the y asymptote -1, but the x asymptote is 2? That's because you just read off the -1 as your asymptote, and for your horizontal asymptote or your vertical asymptote, you check where the denominator is going to be 0, and that we discussed earlier. That the denominator will be 0 if x is 2. Okay, there's a few questions in the chat. Let me just see. Okay, Lakaya, y-intercept. Over here, we make x equal to 0. X-intercept make y equal to 0. Y-intercept make x equal to 0. Always. Okay, that is always what you do to get your y-intercept. Do we not work out the coordinates for the bottom sketch? I'm not sure what you mean. What coordinates, Andiswa? Maybe if you could just let me know what you mean with the coordinates. So Sanda, the hyperbola's got 2 parts to it, okay? 2 parts, 1 graph. You have to have these 2 parts to it because they are mirror images of each other. No, Belinda, oh, maybe that's what people are meaning. Yes, of course, you can put a coordinate point for the 4th quadrant. That is very true. You can do that. I'll add that now once I get through all the questions. When should we show the axis of symmetry? Do they tell us or what? Lichle, I'm about to get to the axis of symmetry. They will tell you. And I'm going to show you now about the axis of symmetry. Okay, so let's do an additional coordinate point because I can see there's a few people who think that we should do that. So let's do it. I'm going to take x is equal to 3. So if x is equal to 3, then my y is going to be, I can just make y equal to -1, 3 minus 2 minus 1. Ms. Kaka, could you maybe help Tato? Still confused about drawing shapes after drawing asymptotes. Yeah, so Tato, after you've drawn your asymptotes, the graph will always be this shape because it's a hyperbola, and then you just place it in the 2nd and the 4th quadrant because A is negative. Okay. Back to calculating this point though. So this way, where does the 3 come from? Feliswa, you choose your coordinate point, okay? In the 4th quadrant, you can choose any coordinate point. I chose 3, you can choose 4, you can choose 5, you can choose any point, okay? It's up to you. So this means we get minus 1 over 1 minus another 1, that's minus 2. So my coordinate point for the 4th quadrant, the one that I've chosen to calculate, where x is equal to 3, is 3 and negative 2. You can choose your own one, okay? Right. Okay, so as I was saying about the axis of symmetry, let's calculate those now. The question will specify, okay? So it will definitely tell you to draw the axes of symmetry. Now, as I was saying earlier, the hyperbola's got 2 axes of symmetry. Also, something you must know, it's a characteristic of the hyperbola. It's like you must know this off by heart, okay? You must know that it's got these 2 axes of symmetry. Y is x plus c, and y is minus x plus c. So it can either be x plus c or y is minus x plus c. Now, how are we going to find out what c is? We do that by subbing in the point where the asymptotes cross. So if you look here at this point, let me make it a different color. This point here, what are the coordinates of that point? Well, this line is x equal to 2, so the x coordinate will be 2, and the y coordinate will be minus 1. So that we sub in. Because our axes of symmetry are always going to go through that point, okay? Make sure you understand that your axes of symmetry will go through that point always. That's just one of the features. But if you look at the hyperbola as it is at the moment as well, think about what symmetry is. Symmetry is like folding your paper and making an imprint. So if we fold this parabola through the axis of symmetry, it must make the imprint on the other side. I said parabola, but I meant hyperbola. So let's sub in this point. Y is equal to x plus c. So y is minus 1, x is 2, and then that's minus 3. And then we do the same for the other axes of symmetry. We sub in the 2 and the minus 1. So on this side, I'm going to have 1, and that is equal to c. So the equations of my axes of symmetry are y equal to x minus 3, y equal to minus x plus 1. Okay, so what is that going to look like? Let me draw these axes of symmetry in green. So the one has a positive gradient of 1, and it cuts through the y-axis at minus 3. So it's going to look something like this. That's my one axis of symmetry. And my other one is minus x plus 1. So it goes through goes like that, plus 1. Okay, so those are your 2 axes of symmetry. And the way to calculate them is also always the same. You must know this part here. Y is x plus c, y is minus x plus c, and that these axes of symmetry always go through the point where the asymptotes intersect. Okay, that point that I showed you, where the asymptotes intersect. And that is the point you sub in to solve for C for both of these equations. And then that's how you get the equations of your axes of symmetry for the hyperbola. Okay, so each graph is different, tells its own story. So that's how you do it. Okay. Can I see in the chat, how are we doing with axes of symmetry? Everyone happy? Please put a thumbs up. Okay. So for hyperbola, there's quite a bit. It seems like until the exams. It's just because of the pressure. That's why. It's the pressure that makes it all different. So hyperbola, as in summary, if we can just look at it again, 2 quadrants, okay? You're always drawing in 2 quadrants. You've got 2 asymptotes, a horizontal asymptote and a vertical asymptote. You've got 2 axes of symmetry, okay? And they both run through the point where the asymptotes intersect. X-intercepts are found in exactly the same way as always, making y equal to 0, and your y-intercept is found by making your x equal to 0. Zamokukle, the question will specify either both or just one. One with the positive gradient or the other one with the negative gradient. So you must just read the question very carefully. Okay, so do we want to draw another parabola or hyperbola, or can we move on to finding the equation of a hyperbola? So I'm going to put, oh, we can take a vote. Option 1, you can vote option 1, draw. Option 2 is equation. So you can vote option 1 or option 2 in the chat. 1 for draw, 2 for equation. Oh, I think we split, Miss Coco. What do you think? I think
this is a tough one.
Hey?
This is tough. It's like 1, 1, 2, 2, 2, 2, 2, 1, 1, 2.
Oh, it seems like an even split.
Now I have to go back and count them all and see how we're doing to see which one. I do feel like 2 has the majority vote at the moment.
Do you think so?
But I suspect if we put option 2, we're going to get back to the same ideas that we had in option 1 or in drawing.
Yes. No, you're right. You're right. Okay. A proper poll.
We'll have a
Sorry,
proper
Anza, it does take some time to set up those polls. One will be helpful for people who battle to understand. Look, there's never enough practice. Okay, so let's do one more. Okay, one more drawing, sketching. Okay, so let's do sketch the graph of the. I hadn't planned on doing another one, but that's okay. We can do another one. Graph of so you guys can rest a little bit while I quickly think of a hyperbola to draw. F of x equal.
You know, Teacher Marlies, around this time, the grade 10s used to ask me, well, I offered to sing to the grade 10s. They refused. They refuse that I sing, but I suspect when you're busy right now, I could possibly sing. I mean, I don't know what my voice sounds like, but just to entertain, who knows?
Ms. Coco, I'm more wondering, what will you sing?
That's a good question. No, I'll be nice. I won't subject them to my voice. I only sing in the shower. No, we don't want to break the internet. Maybe next time. Maybe next time. I promise. Next time I'll sing for you guys. I'll get my vocal, my voice ready, guys. I promise.
Axis of symmetry. Okay, there you go. Okay, I'm gonna give people 5 minutes to draw this hyperbola. We should all unmute and sing the anthem. And do so, maybe we do that at the end. Let's draw a hyperbola and then we can it will actually be really nice. I like the idea, Ms. Coco. But let's draw a hyperbola and then we can see maybe there's time for a song.
Yeah, for a sing-along. I'll lead. I'll lead.
You lead, because I most certainly will not lead in song. I will lead in drawing hyperbola, but I will not lead in singing ever. Right, Lekaya, you say you're done, so you can, I've started doing the questions, so you can check as I go along. I hope you remembered your axes of symmetry as well, eh? Hmm. Okay, yes, that's right. The x-intercept 0, y-intercept is 0. There are my asymptotes. And now I think we are ready to draw. Going to do asymptotes, x equal to minus 2. It's minus 2. And then y is minus 1. And we are drawing in the first and the third quadrant. So for our axes of symmetry, goes through this point minus 2 and minus 1. And we have y is minus x plus c for the first axis of symmetry, and the other one is x plus c. And then we sub in for both that point where the asymptotes intersect, because both axes of symmetry are going to go through that point. So this is minus 1. So minus 1 is 2 plus c, and 1 is c. And then the other one, we do the same, minus 1 and minus 2 plus c.
Ma'am, I think the first one is actually negative 3. Because the 2 will go become negative 2, yeah.
Thanks, Ms. Coco. And then this one will be 1. Yes, our axes of symmetry are minus x minus 3 and x plus 1. And if you draw them, they must go through this point. It's much easier when you have a ruler. So that's 1, and this will be minus 3. Okay, and this one, we look at the equation. Okay, guys, one last time about the asymptotes, okay? We have done a few now, and I have repeated it a few times. So you look at your equation, whatever is going to make your denominator 0, whatever that x is, that is your vertical asymptote, okay? So for this equation, we can see that minus 2 is going to make your denominator 0. So x equal to minus 2 is your vertical asymptote. Your horizontal asymptote comes from here, and that in this case is minus 1. Okay, I hope everyone got their hyperbola correct. There was another question here about what we need to have in order to sketch a graph. So like we need the x-intercept. I think that's what we've been doing this lesson and in previous lessons. this is what you need. You need the shape, you need the asymptotes, x-intercept, y-intercept, axes of symmetry for hyperbola. And then in our previous lessons on parabola, very similar, you need the shape, you need the turning point for the parabola, and you need the x-intercepts and the y-intercepts. So if you can't remember it that well, you're welcome to also watch our recordings. The recordings are all available on our website. Okay, right. I think that is it for this evening, Ms. Coco. We are right on time. And thank you, everybody. We'll be back again on Thursday when we will be finding the equation of the hyperbola. In the meantime, yes, please make notes and make sure that you are on top of your hyperbola. And then we can get going on finding the equation and then getting to the exponential graph as well. It was lovely seeing you all this evening, and I hope you have a great week further. Good luck to those who are writing exams. Oh, okay. Let's see. Ma'am, to figure out the x-intercepts, do you not times the fraction by x plus 2? Figure out the x-intercepts, do you not find the times the fraction? That's exactly what we did. Yeah, that's exactly what we did. Have another look. We took the -1 over to the other side, and then we times by x plus 2 on both sides. Remember, if you do it on the right-hand side, it's going to cancel. So if you do it here, x plus 2, then that cancels out, and x plus 2, that cancels out. Well, that doesn't cancel out, but the other side does. Okay, one more question. Does our hyperbola graph have domain and range? Yes, Lichle, it does. All graphs have a domain and range. It's x values and y values. It's something that we can look at a bit more in coming lessons. I haven't prepared a homework question for you, Nkolise, but have a look at your textbook. I'm sure there are some exercises in there that you can use. Now we must sing.
Oh, I thought you guys would forget. Oh my word. I was hoping you'd be so distracted by the maths that you guys would forget.
Lisa, yes, we have done other graphs. We've done the parabola. Please have a look at our recordings. They are all available on the website. Yes, Tato, that's the next one. We will do graph interpretation. The domain is x is the element of real numbers, but not equal to -2. That's right. It's all the x's except -2. So it's basically all the x's except your asymptotes and all the y's except your asymptotes. Rightio.
That's 6 o'clock on the dot this morning. I think we're going to say goodbye to everyone.
That's
now.
it, guys. End of lesson. Lovely to have you all, and thanks for the questions. I really enjoy answering these questions. We'll see you on Thursday, and maybe we'll sing.
Oh, no. Guys, we're out of time. You know what? On Thursday, I will make a point, guys. I'm going to go practice my voice. We will sing on Thursday. Bye, everybody.
Bye, everybody.